Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
And I'm Rich Gear, your co-host. And Doug, I'm going to let you take this ball and run with it. Is that where we're going to go? Or maybe...
Yeah, we'll talk a little bit about my experimental days when I was a mad scientist.
And we'll hope the show will move faster than a snail's pace, right, Doug?
Right.
Okay. So what is this? Quantifying the left-handed amino acid dilemma, the tale of the snail, an article by Douglas B. Sharp.
Yeah, this is about to be put on the web.
All right.
I'm having some people check my math to make sure I'm good with this, because there's quite a bit of figuring I did in trying to come up with this illustration that I think you'll enjoy. What I
You've
have
checked
to
it
say.
several times yourself already, though. I assume.
Yeah, I've checked it out pretty much several times. Just got to make sure that my figures are correct, and so I'm going to have somebody else go over it.
All right, so what's the premise of this thing? First of all, we have talked about left-handed and right-handed amino acids and things of that, but for those who have not seen it, we probably should, go over and encapsulate what we're talking about here to start with.
Well, this is something that actually got me started with the whole creation evolution issue.
Way back in the day.
Yeah, back around 1967.
Oh, I thought it was turn of the century, but that's all right. Anyway,
well, the Miller-Urey experiment wasn't done at the turn of the century.
Okay.
I was in high school, and I liked to create these mad scientist experiments. And
Right.
what I wanted to do was to build a Van de Graaff generator. And
I remember that.
And that thing had a dome on the top of it that looked like this. It stood about this tall, and it had a belt that had like a 5 horsepower motor down the bottom. The belt that runs up and down like this. And what it does is it piles all these electrons up on this
It was really cool looking.
on this dome, and you stand about 6 feet away from it, and you get a spark.
Yeah.
And if you stand even closer, you get some real lightning.
Yeah.
It's
It was
pretty
cool.
freaky. Yeah.
It is freaky, but it was cool. I remember that.
Make your hair stand on
Going
end,
down
that
in your
type of
basement
thing.
seeing that thing. So.
And if you figure that 50,000 volts is about a half an inch, you can figure 6 feet. That's quite a few volts in terms of static electricity that you're
Yep.
producing. And so it was a lot of fun, and I entered that in the science fair. Well, I didn't win first prize, but the guy who did actually had one himself, and he had it connected up to a experiment where he was actually duplicating the Miller-Urey experiment, which is a
Yeah.
mechanism where he was taking the sparks from this Van de Graaff generator, and he was had an atmosphere in this globe of
The famous methane or
methane, water, ammonia, and
yeah.
hydrogen gas was supposedly the
primordial
atmosphere of the Earth. And
you know why that is? Because oxygen will kill you. If you kill anything from they're trying to do amino acids or proteins so they can, hopefully the building blocks of life is shown by evolutionary naturalistic processes. But oxygen, we know, will basically stop any of that from happening. It'll corrode and it'll mess everything from building together. So we're not going to.
Well, you get the wrong thing.
You get the wrong
basically,
thing. Yeah, it just won't
when
work.
you have oxygen presence.
Of course, the problem with that is, Doug, is they found oxygen in the lowest, what they consider Precambrian rocks. They found embedded with oxygen, so they've kind of thrown that out. Now today.
Well, we're not here to
discuss
Miller-Urey experiment, because what we're going to do is assume that this was true, and this is the way it happened. We're
gonna
give them the benefit
give you the benefit of the doubt.
You
Okay.
can create amino acids in this test tube, and you can collect them in their little trap down there, which is really cheating. But
Yeah, we know that's
neither
cheating.
here nor
Everything they
that.
stay. Yeah, okay. We're going to give them
Anyway,
everything, right?
We'll give them this, these amino acids, which are the building blocks of proteins, and you string them together to produce proteins. And the sequence in which you string them together produces some sort of meaning, and this meaning is what really produces life. Combining these amino acids together to produce the proteins is what causes your life to work. And the way that the proteins work in your body is really amazing, because what these proteins will fold up in a little ball. There's sort of like a default spiral that it has, but if the side chains of these amino acids, they differ, they have different characteristics, and some attract each other, others repel each other, and because of that, they'll fold up in this ball, and these weak bonds hold it together, and it's that has actually a meaning. It does certain functions in the body. It takes stuff apart and puts it back together, and
Right.
processes your food, and does all that sort of thing. And so my experiment was, hey, we can create life in a test tube by because amino acids were produced by this Miller-Urey experiment. So obviously this tells us that life evolved in this mechanism. And so my idea was
Which
to
is
take
not obvious, but we'll give you that.
yeah,
Okay.
but it's the illusion that is popularized
Right.
by the media. And so what I said, well, I wanted to take it to the next step. The next step in my mind was to be able to combine them together to produce proteins. And you have to remove a water molecule between two amino acids in order to do that. Well, that's a problem too. We'll give them that. We'll say
We're giving away the farm here, Doug. You know.
yeah. We'll say well, this mechanism is fine. We're going to but what we're going to do is discuss the one aspect that I ran into a problem with that I couldn't get around, and this was something that number of early creationists, A.E. Wilder Smith was one, and James Coppage was another. He wrote a book, Evolution Possible or Impossible, and you
Is he
borrowed
still alive,
it.
Doug? Is
He just passed away. Coppage just
yeah,
passed away
okay.
a few years ago.
Because Wilder, I think, passed away in the 70s, 80s.
Yeah, he was 99
Yeah,
when
he
passed.
was a guy.
He had 3 PhDs.
Did he really? He was
Yeah.
he was a smart guy. Yeah.
But anyway, Coppage in his book mentioned the problem that amino acids, all except for one, have stereoisomer characteristics, which means the Miller-Urey experiment produced them in equal mixtures of left-handed and right-handed configurations. The left-handed configuration is the only one that life uses. The right-handed configuration life doesn't use. However, if you produce it by any mechanism, even other than the Miller-Urey experiment, you're going to get equal mixtures of both. And one problem is that if you have pure left-handed amino acids outside of life, what happens to them is that they racemize, which means that they spontaneous go to equilibrium between the two different configurations.
So if you had more left-handed ones, they would like flip around. Some would turn into right-handed ones.
That's
Is that
right.
what
That's what I'm saying.
Okay.
Is that they
I didn't know that.
they like to go towards equal mixtures of both.
So life we know is sort of like it's like an outrageous anomaly. In other words, based on naturalistic processes, we should not. You're saying we should not be here, okay? Because life always uses left-handed only.
Right.
Now, do they know why that's the case, Doug? Do you know why is it only left-handed? In other words, could
To
life
me,
conceivably
it's
work with
the
left and right?
signature of God. And
Yeah, I know, but I'm just saying. Other than that, I'm saying, is there some reason why it's only that way? I mean, could life conceivably use both right and left-handed? Because it doesn't, right? It's always left-handed, totally, right?
That's correct. There's no chemical reason why it should be either or, except that it seems to be a material that God used to actually provide meaning. It is something that was a consistent way of doing things, and so God took this and put it together in this particular mechanism so that you would have everything consistently. Otherwise, it would be bent in the wrong direction.
Well, what's interesting, it sounds this again sounds that book he gave me a book called The Biotic Message. This is like the signature work of a creator. It's kind of like elegantly simple, and yet so unbelievably like strange that the signature is there. In other words, you can see the handwriting. There's a signature there. On one hand, you're saying, well, all life is this, so it all evolved from one thing. Then it's from one cell or one whatever it is. But you go, wait a minute, but why would it stay that way? In chemical, it all flips this way, and it all comes out even. Why does it always go this way? And it's so simple, yet complicated all at the same time. There's a signature.
Yeah.
It's like there's like a statement there saying, I'm doing this so that I'm telling you something's different here.
Right.
And it only works in life, because you say in non-living things, does it go equal left-handed, right-handed, right?
Right.
Yeah. Okay.
So anyway, let's talk about
So
Coppage's question.
Coppage is it Coppage or what Smith?
Coppage,
Coppage.
Coppage was the one who produced this particular argument.
All right.
He
And what is
says
it?
that the average length of a protein is about 410 amino acids. Now, he had come to that calculation by a number of mechanisms, and so we're not going to go there. But what we'll use his argument, and what it's like is flipping a coin 410 times, getting heads each time.
Okay. It could happen.
And so that is a question: is what is the odds of doing that? There's one. It's 2 to the 410 power, which, or it would be 10 to the 123rd power, which that's what it works.
You get
out
in
to be.
numbers. All I know, that's a big number, Doug. How big is it?
Well, it's 1 with 123 zeros after it. And
Okay.
so, what the thesis of this little article is to actually quantify or give you an idea of what this number is like.
In
And-
other words, what are the actual odds of this happening? And you're going to give us an
Okay.
illustration what it is, right?
And so the idea is I'm going to set up a race here, and the race
Here
is
we go.
between an experimenter randomly assembling proteins at a rate of 1 mole. Now I have to explain what a mole is.
It's not something that
but
digs in
it's,
the ground, eh?
You produce 1 mole of proteins every second. Now a mole is it's Avogadro's number, which is 6.02 times 10 to the 23rd power molecules.
That doesn't mean anything to me, Doug. What does that actually mean?
Okay, this is a huge number, but what it is that if you actually produce it, it is a measurable weight. And in this particular case, the weight of this particular protein would be like 32,000 grams, which is a fairly significant
size.
amount. It's a big experiment. Okay.
Yeah. All right.
Okay, and so we're going to produce that much every second, and so we're going to crank this stuff out continually, and it's probably far more production than any automated equipment that we could ever
Right.
put together.
I've never seen anything that could do anything that much. Okay.
And so we have that type of experiment going on. Now what we're going to do is ask the question, how long is it going to take for that experiment to go before we actually get a protein that's usable in life, that has all left-handed amino acids?
It's 410.
Right.
Amino acids,
It's going to
okay.
have 410
Left-handed.
left-handed amino acids that are going to
All
be
right.
usable.
Now we got you.
And so that is one end of the race that's going to be set up. The next end of the race is going to be the snail, and the snail moves at 1 millimeter in a million years. And so he's pretty slow.
That's slower than most snails I know right now.
Right. And his
Okay.
job, our snail's job, is to move the entire Earth over to the other end of the universe and back, as far as the edge of the known universe, 1 molecule at a time. And we're going to assume that the Earth is entirely water for the sake of the calculations. And so what we... So what I
Again,
did
you're
was I
simplifying.
worked
By doing it, you make it even easier for the 32,000 grams of people to win.
Yeah, 18
Okay.
grams of water is a mole. So
Okay.
I also use the mole for water. So it's what it is the molecular weight of of the object, and it works out to this number in grams.
Okay.
And so that's how they figure that out.
So we got a complicated thing here, but hope stay with us here, sir. You're coming down to it, all right?
Right, and so here's this snail. He sort of squinches along at a very slow pace doing his task. But every second they're cranking out these proteins at that particular rate. Now, what I found out that was after I did all the calculations, and I'll sort of go through them for you, is that the snail will win the race. And by the time the snail has moved the entire Earth from one end of the universe and back,
And he's moving one
molecule at a time.
and he's moving a centimeter every million years.
1 millimeter. Okay, that's this far.
He's moving a millimeter in a million years, and he still would win the race.
That's right.
Before you get enough left-hand amino acids to make one viable protein.
Now, I figured out that now if
That's a
I
big
actually
odds.
wanted to give the DNA, I mean the protein, a chance to actually work, if they would get what would be the possibility? You'd have to produce out of this 400 tons every second,
Okay. Ooh.
which is about 10,000 times the mole weight. So instead of 32,000 grams, what you're going to have is 10,000 times that. So it's 365,269 kilograms.
You're
is
producing
what-
that now every second.
You're producing that every second, so that works out to be 400 tons.
400
And
tons a
so
second of life.
If you produce at that rate, you have a small chance of beating the snail. So
Probably, this argument is it's a little esoteric, and a little bit big to grasp, but the concept is it's just.
well, what
You
you
say
have to do is
I mean, this is impossible, Doug.
well, it certainly is.
Yeah.
And I thought I'd just run through how I did these calculations.
Yeah, do
I
tell.
started
See if I
out
can understand you.
with the volume of the Earth. The volume of the Earth is 10 to the 21st power cubic meters,
Okay.
and that actually ends up to be 10 to the 27th power milliliters. So we're talking a huge number already. Okay,
Right. Yeah.
and then what I did was I actually figured out, well, how much water would take up, how many molecules there would be in the volume of the Earth. Okay, and so that's let me see. I used the molar calculation, which is 10 to the 23rd power, 6.02 times 10 to the 23rd power. And so therefore the Earth has 3 times 10 to the 51 power water molecules. So we have a big number, but we're less than halfway, okay? And so therefore we have to say the snail has to make 10 to the 52 power round trips. So he's got to go back and
gotcha.
forth.
I see where you're going. Okay. That's a lot of trips, isn't it?
So then
And
I
he's
figure
moving a
out,
millimeter every million years,
right,
and he's got to make 10 to the what'd you say, 52 power?
or 10 52 power round trips. And so now the
Moving
edge of the
millimeter in a million years. Okay, all right.
so the edge of the universe, the known universe, and I'm using the bigger number, okay, 20 billion. Let's say the Earth known universe is 20 billion light years. Well, we know
Which they
now
bu-
they've reduced that to about half of that.
Yeah, about 8 to 12. Yeah.
And so light years is just less than 10 trillion kilometers. And so the distance the snail has to travel is 10 to the 29th millimeters, okay?
Just a silly millimeter long.
Okay,
huh?
and so then I have to figure out, well, there's 31 million seconds in a year. And so he travels 1 millimeter in a million years. It takes
And you think
about-
I'm obsessive compulsive, man? This is some numbers, man.
it'll take him 10 to the 95th power seconds for the snail to complete his task. Okay, so
We're trying to get the bleep response off of our audience here, Doug. These numbers are humongous, man.
Yeah,
But they're so big I can't even fathom them. All right, keep going. All right.
okay, if our experiment produces 1 mole of protein every second, it'll still take 10 to the 99th seconds for it to produce 1 viable protein. And so that's the conclusion. 10 to the 95th, but compared to the 10 to the 95th power, the snail wins 10,000 times over. You can still make 10,000 more trips back and forth before the you'll
For
have
one,
it.
and you're talking about one lousy protein.
Right. Okay, now the problem is you got a protein. Hey, let's give him all the proteins that you want. Okay, now you got to get them all together in one spot. Maybe at least 100 of them to form one viable life form.
Piece of bacteria or something, huh?
Okay, and somehow you've got to get this life form to reproduce and to.
The evolution would say, Doug, it could happen. But now we want to know who's got the bigger faith in this whole. It could happen. Well, it had to have happened because here we are.
That's the argument.
That's how ridiculous these arguments are. It happened because here we are. That's how outrageous these claims are, and they make the creationists sound like the idiot. And I'm going, do you realize how ridiculous that is, Doug? If what you're saying is even remotely true, and it sounds like it's all true,
Right.
that's outrageous. It's kind of, to get to that, where you're putting it together, you're saying, okay, this number, and try not to get the glazed donut look where you're kind of going, well, I'm glazed over all these numbers, but Doug, that's outrageous,
No, I think it was Fred Hoyle that said that he gave, and he's not necessarily a creationist, and
No, he's not.
not so much at all, but his figures was 1 chance out of 10 to the 40,000th power. So there's 40,000 zeros after the 1 instead of just 123 zeros. And
So it's even worse with this.
Oh yeah, it's.
Well, yeah, but he's got the solution, Doug.
Oh yeah,
It's aliens.
yeah, panspermia.
I mean, could you think of how ridiculous? Look, we've got people that are smart, Doug. We're not talking about panspermia today or aliens per se, but people like Carl Sagan and Hoyle and other guys. These guys are brilliant people that they realize what you're saying is so true. You can't get here. Like Hoyle said, it's like trying to build a Boeing 747, but with a tornado in a junkyard. Kind of that a tornado passed through a junkyard. The idea is they've had to appeal to something equally ridiculous: outer space aliens, and people are pushing this off as science. This is how outrageous it's become now.
Now, I remember going through the MSU library, and I found a big, thick book about this thick that said it was a proceedings on a conference of trying to resolve the left-handed amino acid problem.
Oh, they've actually
There was all these articles that they had in this big, thick book.
right.
All of them failed. All of them had what they were trying to do was to exploit some.
But Doug, was it
little
10 to the
characteristic.
123rd power failures? I'm kidding. I'm just.
But they were trying to exploit some minor differences between the two right-handed and left-handed configurations of the amino acids to produce a pure, all pure left-handed form. And every one of these experiments met in failure.
And by the way, Doug, this begs the question: all these experiments were done with intelligence behind them, and they still failed.
And
Okay.
here's the other thing, is that recently there's been an article published by some Nature magazine or something like that. I don't remember what magazine it was published in, but it was talking about a meteorite where it was, they had actually found on the meteorite some left-handed amino acids. They theorized that, well, as it was traveling through space, it hit polarized light from the sun. And
that's creative.
It spontaneously caused the amino acids to become left-handed. Well, they forgot that when it landed on the Earth, it probably landed in a field where there was a few leaves or stuff, and probably contaminated the sample with left-handed amino acids.
Samples are never contaminated if it gives the evolutionist what he preconceived in his mind that he wanted it to be. Never. Yeah. It's like dates of the Earth. They're always perfect if they give the right date. If they're wrong, then they're contaminated.
It's called the Murchison meteorite or something.
Oh, really?
I think it was included in the article because the whole idea of actually that they proposed to produce the left-handed amino acid naturally really doesn't hold up to light.
Well, because I remember reading about that light thing, and I didn't. But you're right about hitting the ground, because that's what some of the people think about the meteorite rock that was so big hoopla several years. Yeah, the Mars rock and those things too. Of course, that didn't even have any DNA; just had some squiggles that looked like it might have been precursors. But still, Doug, what you're saying is like, and these arguments, these are like old arguments, but they still hold up, and they've never been refuted as far as I could see.
No, I've been looking for, ever since I've seen this, and this is the one thing that actually convinced me was airtight argument, Class A evidence for creation was this a particular argument. I've been looking for evolutionists to come up with an explanation.
Well, the best,
and they've never been able to do it. This has been a outstanding argument that I think that, and this is just only scratching the surface. This is only one of hundreds of problems that you could bring up concerning the origin of life.
Well, that's the thing, Doug. Our time's getting shorter, but it's like before you get to Archaeopteryx, whether it's a bird or a dinosaur, all these transitional. You got to have some inanimate, non-living thing become a living thing. You have to do that by these amino acids combined together. We didn't even talk about the sugars that you need. They're right-handed, aren't they?
Yeah, the sugars are right-handed.
Right-handed. It's like, what the heck is all that about?
Lipids are cis rather than trans, and the cis is a more unstable configuration than the trans.
There's all kinds of weird stuff like that continues and continues and continues. It's like we've only showed you the odds of one component of life being inordinately impossible to ever happen.